All right, here we are in chapter 3, talking origin symmetry. Origin symmetry. So we know that symmetry is like a reflection or something that you can fold, like making those hearts in elementary school. But now we're going to use this definition to check to see whether these are symmetrical to the origin or not. So I'll get back to this part of the definition. It's in two parts. It's this part and this part. I want to show you how to use this right here. Okay, this says a function is symmetric to the origin if and only if f of negative x equals negative f of x. So what we're going to do is two problems. We're going to first do f of negative x, and then we'll turn around and do negative f of x. Okay, those are two different things. If they're equal to each other, the answer is yes. So what I'm going to do is I'm going to do this right here, f of negative x, and I'm going to plug in negative x right here for this x. You see that I substituted. Anytime you substitute something, you need to put it in parentheses. Now we're going to figure this out. So negative x cubed is just negative x times negative x do over already negative x times negative x. That would equal negative x cubed. And it would be, because this is like -1, -1, and -1. So -1 times itself 3 times is -1. But we're not going to write that there. So that's what that equals. I'll put a little circle around that. That is f of negative x. Now I'm going to do negative f of x. And what that means is just take -1 times f of x. Okay, I put a dot there instead of a times. Just take a -1 times this thing. So I'm just going to do -1 times x cubed. -1 times x cubed is -1x cubed. So negative f of x equals this. And then I ask you, are these two things equal to each other? And the answer is yes. Therefore, this is symmetric to the origin. It has origin symmetry. I will come back if I have time to the graph of this. But let's go over here and do it to this thing. Okay, let's do it to this. So if I'm going to check f of negative x on this. All right, I'm going to plug in negative x everywhere I see an x. Now be super careful here. Watch this. That's how that is. So it's 1 minus negative x. Don't be trying to skip steps on these parentheses. That's super important. Okay, so this is going to equal on top negative x, on bottom 1 plus x. And that's it. There is no more simplifying that you can do to that. That is f of negative x. Okay? You can't cross these x's out. There's no way you can do that. All right. Now let's try negative f of x. Negative f of x. There we go. So this is -1 times x over 1 minus x. All right. The answer is negative x over 1 minus x. Now, I ask you, did you miss something there? Did you see that? How I did that? This is the negative f of x. If you're like, I don't know how he just did that, let me just remind you of some pre-algebra here. If I take a -1 times a fraction, something over top of something else, like 2/3, this is -1 over 1 times 2 over 3, which is -2 over 3. That is exactly what I did here. I just simply took -1 times x and made it -1x on the top. Okay? It's the same principle as 5th grade math here. Okay, same principle. So these two things, are they equal to each other? And the answer is, of course, no. Now, if we quickly, let me see where I'm at with time. Okay, let's quickly look at the graphs of these. Okay, so I got a graph set up here, and this, I'm just going to do the first one, just the x cubed. that graph looks something like that. Now this is a classic case of origin symmetry, because getting to back to this part of the definition here, it says a graph S is symmetrical if point AB belongs to it and also negative A, negative B belongs to it. So if I make a fictitious point here on the graph, okay, I'll make a X, Y table here real fast, and I'll show you what happens. If I pick point 1 for X, and I plug 1 in there, 1 times 1 times 1 is also 1. So 0.11 should lie on this graph. If that is true, then negative 1 also lies on it. Let's try it. So if I plug in negative 1 right here, that's going to be negative 1 cubed. What's that equal? Well, negative 1. So point negative 1 would be right there. And any point here would also have its opposite image here, 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 and so on. Okay? So that's a classic example of origin symmetry. And if you graph this one here, you will see that it doesn't work like that. But this is usually the classic way of telling whether something is origin symmetric to the origin.